Hi Year 10s, here are your 4 experiments: the drop, the reaction, the pendulum, and the tomato plants. I'm going to show you now how to get your graphs and how to, questions you can ask yourself and to see if your results were good. So the drop. Graph should be height in meters versus average time squared, so that'll be second squared. You collected just the times, so we have to square them first. So let's put a column over here, equals the time squared. And there they are. So now we'll graph it. Then we just check everything's on the right axis. So it's height versus average time squared. So height goes up to 2.5. Yep, up to 2.5, so that's good. Now, of course, what we should do is add all the titles, etc. But actually, maybe I shouldn't. Height, centimeters. Down here, it's time, I'm just going to write squared, that'll do for now. When we look at this graph, first we click on the point, any point, doesn't matter, then right click, add a trend line. Over here we've got different options. So linear is the one that we use, it's already highlighted. And we want to display the equation and display r squared value. And that's it. So there's our graph finished. Now we check whether it went well. First I see the points, they're pretty good. There's one below, one above the line, the rest are kind of on the line. So it shows a very strong 98.86% straight line. So it's virtually perfectly straight, just not quite. So that's a good result, because it's supposed to be a straight line as it says here. It's also supposed to go through 0, 0, which is down here. Now you can see up here, that also tells you if it goes through 0. So it doesn't quite go through 0, it's a little bit above 0. So that's something to look at. What else? The gradient should be 4.9. Well, here's the gradient. It's 4.7434. So the gradient's a bit smaller than what it's supposed to be. So when we look at the graph, first of all, to make the gradient bigger, I might just show you what I mean by taking it over to a different screen. So let's just say, because that gradient's too small, it was meant to be supposed to be 4.9. So we could make this gradient bigger. For example, if this point was higher, or if this point was further to the left, that would make the gradient a bit steeper, wouldn't it? So that's one thing. Or if this point here was lower, or further to the right, or a bit of both maybe, that would make the gradient steeper too. Now, if the gradient gets steeper, it gets closer towards 4.9, and if the gradient gets steeper, instead of cutting through at above 0, if we get it just right, it might now cut at 0. So all you have to decide now is, which one do you think is more likely? Do you think this is the point that's wrong and needs to be further down or further right, or is this the wrong point? Does this point need to be further up or further left to make this the gradient steeper? And that's what you have to start thinking about. Yeah, that's of course if your gradient is smaller than what it's supposed to be. If the gradient, let's just say for this, let's do it again. Let's say your gradient is said here, it said what if it said 5.5 or something, and it's supposed to be 4.9? Then you'd know your gradient's supposed to be smaller. So again, this point, maybe it's lower down, or just more to the right to match that line, or maybe this point is further up or more to the left to match that line. So there's the drop. Let's look at the reaction one. The graph should be average rate, so percent per second, versus concentration. So at the moment we've only got time. Now, the rate, or percent per second, is 100 divided by the time. Whatever the time was in seconds. You must work in seconds, not minutes or anything else. So if you had 2 minutes, 10 seconds, you have to change that into seconds. So 2 minutes is 120 seconds, plus 10 seconds, that's 130 seconds. Okay, so be careful of that sort of thing. So, we want the rate, that equals 100 divided by the time. And drag those down, and then we can graph rate versus concentration. So now we've got rate and concentration. Use the control button to highlight 2 separate columns. Then we insert a scatter plot. Again, we check to see if everything's on the right axis. And remember, rate had to be on the y-axis. So it should be going up to about 3.1 as the highest. Only goes up to 0.5. So it's the wrong way round. Let's delete it. And then we'll just move this over to here. Now be careful, because we used a formula to calculate that. See the formula? If we move this column, when we paste it, we just do the paste values. Otherwise it'll paste the formulas and it'll be reading in the wrong place, because this reads to here. If we move this to here, see how this was reading 2 places to the this was doing a calculation on this column. So if we now copy and paste it over to here, this will do a calculation on this column, because we told it to calculate to its right. That's what we have to do, the paste values. So right click, it's that one, paste values. Okay. Now let's try it again. We'll highlight our 2 columns. Now let's check it. So rate was on the y-axis, and it goes up to about 3. Yes. Okay, that's better. Again, click one of the points, right click, add trend line, yes, linear, display equation, display r squared, and there we go. We got our line. The graph should be a straight line going through 0, 0. This one nearly does. It's just a little bit too high. And the gradient could be any number. So, what we have is a situation where it's cutting across. I'll grab this. See, it's cutting across above 0, a bit too high. If we extend that line, you'll see what I mean. Not really, is it? It's cutting across just above, so those results are pretty good. I don't have much to say at the moment. Probably need to comment about this one and that one, why they're a bit off the line and think back to your experiment, what you did, what might have caused that problem. Okay, so that one's finished. Pendulum. Graph should be average time squared versus length. So there's time, length, we need time squared. Equals time squared. Okay, now I've just realised there's probably something wrong with these numbers, but let's do it anyway. So we graph our time squared and our length. Oh, that's crazy. I think I forgot to change the numbers actually. So I'll just make them up now. Let's see, I might have to pause this actually. Okay, sorry about that, I've got some better numbers now. Let's start again. Graph should be average time squared versus length. We only recorded the time in our experiment and the length, so we have to square all the times. So, time squared equals that squared. And do it to all the rest. Now we can graph that. Our time squared versus our length. Again, we check to see if the right thing's in the right place. So time squared with these numbers, so time squared goes in the y-axis, so our y-axis should go up to about 9.6. Only goes up to 3, so the information's the wrong way around. So let's copy this, Control C, right click, paste the values only, not the formulas, we just want the numbers. There we go, insert. Now, time squared goes up to about 9. Yep, about 9 for that one. Good. So now we're ready. Click on one of the points, right click, add trend line, display the equation and the r squared. Okay, here we go. We've got our values. Now the graph should be a straight line. 97%, pretty close. We want to get 98%. So you could talk about why it's not quite straight enough for what we want. So maybe that point's to blame and that one, although they're all quite random actually. Probably can't blame any particular point. Next, it's supposed to go through 0, 0. It's at minus 0.5. So if we take it over to this screen, if we extend that line through, yeah, it cuts across below 0. So I should have cut across up here. So something went wrong there. What else? The gradient should be 4. Well, this gradient's 4.244, so gradient's too high. Now, if we were able to, if we go back to the screen, so gradient's too high, but it's cutting across the y-axis too low. So if we could somehow now this new gradient's steeper, sorry, the new gradient's smaller, which is good because it's supposed to be a bit smaller than this. And by making the gradient smaller, that's helped it to cut across the origin instead of at minus 0.5755. So that's actually really good. Now, it looks like this point's to blame. To me, it looks like it should either be higher or more to the left. Now, this is the length of the string. Do you think we made a mistake writing down the wrong length? Maybe the length was really, say, 0.25 meters. Do you think we could make such a mistake? I would doubt it. because, you know, it's pretty obvious the difference between half a metre and 0.25 metre. Or instead, did we get the metres right but the time wrong? Do we make a mistake with the timing? So should the point really be there? That's more likely, isn't it? Because it's easy to make a mistake with the timing. It's much harder to make a mistake with your measuring of the length because you're using it just a ruler or a tape measure. So I'd probably blame this point for this particular graph. Tomato plants. Now the theory says that tomato plants, they like 0.9% salt the best. So I'd probably reckon that this 0.8 would help the tomatoes grow really well. I think this would be too much salt for them. I think these would grow fine because they got, well, maybe not this one because it doesn't have any salt. Because the tomatoes need the right amount of salt to grow. Now, it's quite weird, this graph, because let's just look at the orange one, 0.4%. On the first day, the plants were on average 4.5 centimetres tall. Then they were less tall, then more tall, then less tall, then more tall again. That's strange. So one of the reasons could be is that some plants just didn't really grow, which brought your average down. So for example, if you had 5 plants, so 1, 2, 3, 4, 5, and they're all 4 centimetres. And then the next day, one of them kept growing, but one started to wilt. Another one started to wilt. So that one, well, it looks bad now. The average height would go down, even though one of them might be growing taller. You'd have to check your table to see why the average went down. It's a bit strange, isn't it? It was that tall, then it dropped. So there's plenty of questions to ask. 1.2%, it had the lowest growth the whole way through, so that's expected, isn't it? 0%, well, it had the same, it's hidden, it's actually under the orange one there, so it's pretty good. And then it was the third best, then second best, then it was equal first, because it's hidden under the orange, and then it was the best growing plant, even with no salt. So why is that? Why do you think that even without adding salt, it still grew in the end very well? Is it because there's salt in the soil already and you don't need to add any with the water? I don't know. You've got to think about it. Okay, so that's it, guys. Hope it helps. Ask me any questions if you've got any.